We all set now? Okay. This is what happens when you live stream. You don't have control of your own life. This is the first panel of 3 today. It's on new trends in wireless test equipment. I'm joined by George Ziegler of Cobham AvComm and Tom Boyle of Bird Technologies. Unfortunately, Mike Taleo of Divisor Instruments had a family emergency and could not attend at the last minute. So we're going to start, and basically I have a set of questions that I'm going to ask these gentlemen, and we'll see how they do. No, you're going to sit, and you can activate that microphone. Okay, can you get that? Good. All right, so the first question is, it seems like the test equipment industry is putting more and more features in their analyzers. Can you still hear me, or is it a little low? So it seems like the test equipment manufacturers are putting more and more features in their analyzers. Today they're often spectrum analyzers, PIM measurement devices. They sometimes incorporate digital cable testing and even fiber optic backhaul testing. Are there any compromises in terms of accuracy or sensitivity or other attributes that happen when you try to combine so many things in one box? George, I'll start with you, please.
Okay. Good morning. I believe I'm on. There's always compromises when you add. What's happening now, though, is we're removing the analog component of system management or system processing. So although at the RF level or the audio level, we do capture the signal, but once it's converted from an A to D, everything's done in math now. And the mathematics handles processing, generating the results we desire, and then displaying it back to the user. I think as time progresses, we can continue to add more technology into a device and not worry about introducing inaccuracies or errors purely for that point. We're operating in a DSP environment.
Understood. Tom, you want to comment?
Sure. We don't make a lot of the analyzers you described, but what we are doing is making some of the Bird power measurement devices and embedding them into these analyzers so they're getting the accuracy that Bird has been known for, in the power measurement realm. So Aeroflex is one of the, or Cobham is one of the manufacturers we're doing that with.
Okay, gotcha. Good. By the way, I have a Bird 43. Had it for years.
What year?
I don't know, because I bought it at a Hamfest, and Lord only knows how old it is, but it still works.
I think Bird's coming out with a Bird 43 app for the iPhone.
I had to.
I'm ready. Yeah, there is. Okay, so carrier aggregation is a current term in the cellular industry. Does that present any unique challenges to test equipment designers?
Yeah, I saw that big word there, and I'm not used to syllables, so I had to consult Google for a little help on that one. Carrier aggregation, LTE, multiple carriers to enhance your data throughput. With testing those signals, you have variable data rates and timing of when signals, as far as symbols are arriving, when phase angles are arriving. Do you test it in a high density rate, or do you test it at a low density rate? So it's a matter of your equipment's ability to look at your various digital test parameters, error vector magnitude, your bit error rate, your clock time, your symbol deviations. As far as the problem, I guess the speed of your test equipment would determine how well you could do your sampling to gain the test results you desire. So it's a matter of processing speed, MIPS, 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 and more MIPS.
Okay, that makes sense. Tom?
Yeah, I'll go back to, like I say, into the power measurement mode. And we are releasing new product due to LTE and the need to accurately measure the power of the individual pulses instead of just the typical peak and average.
Gotcha. Some vendors are talking about something they call a deeper view. I'm not really sure what that means. I picked it off one of the websites. It might be proprietary in somebody's mind, but it suggests a slightly different approach, perhaps. Would you guys like to comment on what it means and what the advantages are? And is this one of the trends in the industry?
I don't think we're the vendor that's looking at a deeper view, so that was a surprise for us. We're providing the standards. We view the standards as released, and we try to exceed them with our test capability. So I'm not sure how much deeper you can get into signal analysis unless you're at a design level. But if you're above design and in utilization, you wouldn't need that, in my perspective, from the land mobile radio side right now. I don't think you have a deeper view, do you?
No, not really. I mean, the one thing we're seeing is it kind of relates to a deeper view is better accuracy. So a lot of the manufacturers out here in Silicon Valley and out in Silicon Forest, 1% isn't good enough anymore, so we're actually being driven to 0.5% accuracy with the ultimate goal of 0.25% accuracy.
Now,
I have another point. Go ahead.
okay, but let me just comment on what Tom said. So is that because, Tom, that we have a lot of RF devices that are basically RF on a chip, and they're, on Wi-Fi bands or whatever, and they're operating at 100 milliwatts or very low power levels? Is that the reason why, or is there some other reason?
It's mostly in the fab environment where they want repeatability in the tools that are developing the chips.
Got it.
I've grown up in a world of parts per million, and even the parts per million has gone from 10 down to 1 to a decimal. Lately, I've heard that there's a change where we're going to parts per billion on frequency accuracy. Just want it to be stable, 1 part per. I don't know what comes out the parts per billion. Hopefully, I'm not alive then.
I think it's called dividing the frequencies down further and further, narrower channels, right? When I was in the field, was a very long time ago, and a spectrum analyzer that we had at the time that we carried around was basically a suitcase. It was heavy, and I was carrying it in parts of the world that weren't particularly physically friendly, very hot parts of the world, what have you. And now I look at the stuff that I see at the trade shows, and it's unbelievable. It's about this big, and it's a spectrum analyzer, and it's a signal generator, and it's half a dozen other things. Is there a limit, a mathematical limit wherein we're just not going to get any more stuff in one box, and the boxes aren't going to get any smaller, or,
Somewhere around the 1800s, there was a concern that we're going to run out of coal, and without coal, we're going to lose modern society. And then a colonel in Louisiana found oil, and so, okay, we have another source, another approach to life. I think the Queen knighted him for preserving our way of life. Well, Moore's Law, Moore predicted back in the 60s that we'll be able to double the number of transistors on a substrate every 2 years or so. Somewhere around 2010 or so, he had to modify it to every 2.5 years. And they're wondering, when will that end? 2016, 2017? At some point, we're going to have to come up with another approach to how do we put transistors on a device. So yes, there will be a limit, but at that point, there's someone 5, 6 years old now that's working on a solution, a creative idea that we hadn't thought of today. Maybe we won't use a substrate, use something living or neural technology or something in the future. Equipment will continue to advance. Innovation will continue to occur because the creativity that we have, the desire to do it better or do it different is going to continue. So I don't think we're going to reach a point where this is the last piece of test equipment ever made.
Tom, you have a comment?
You joked earlier about the iPhone app for the Bird 43. Actually, I already have that for the Droid, but
Sorry, you picked the wrong platform.
but we're actually seeing a lot of I'll call remote monitoring, where we leave the spectrum analyzer in the field and I control it and view it on my phone. We now have power measurement products that'll do that. So I don't think we'll see an end of test equipment, but I think you'll see a lot more site visits, because I can put the equipment in the field, leave it in the field, and see it via my phone, my desktop, my laptop.
So it's a decentralization in a sense. You're over a network, you're eliminating site visits, basically.
Yes.
Yeah. That makes sense. Drive testing is a really big deal in the cellular world, as most of us know. The first thing that people do when they change carriers is they find all the places the cell phone doesn't work, and then they call up their service rep and say, you screwed me because you sold me this contract for 4 years and I can't talk anywhere. Of course, I'm exaggerating, but that has been for some time the mantra. Now, most of the areas are built out, but now we're getting to another level where is in building stuff, and we have a whole nother panel that's going to talk about that later. But staying with the outside marketplace, is there more automaticity that you can bring to drive testing to make it simpler? I can remember the days when I was doing the LMR industry. We had 3 guys. One guy was driving, one guy held a radio, and one guy wrote this was pre-computer, so we were writing stuff down. Is there a quicker, faster, better way to do drive testing? Is that coming? Is it going to be improved?
The first drive test I was exposed to was a little difficult because the boxes were square, and we just didn't have that, on the, no square boxes on a drive test. Sorry about that. As what's happening now with the more complex waveforms is a signal leaving, the principal signal leaving the antenna, and a reflected signal off of a building or a natural object are arriving at the receiver. And in digital communications today, you're not just dealing with carrier intermodulation, you're dealing with phase angles and time. Where is the data bit at a particular point in time, at a particular phase? Well, if I receive the same data bit delayed off phase, my receiver is getting some interference between symbols and has to choose. Well, that raises your bit error rate, which diminishes your range. So for enhanced drive testing, your equipment will need the ability to not just read the signal power, but also differentiate on the transmitted bit error rate and segregate the desired signal from the reflected signal. And so I'm not sure how that's going to happen, whether or not there'll be a dual approach where you read the entire signal and then you erase what should not be there. But I believe, again, we're back to MIPS. We're back to how much processing can I do per second and make more intelligent decisions.
Understood. Tom, this is probably not something you have a product for, right?
It's not anything we do, but in a way it's transgressed. And Greg will be talking about it later today with in-building DAS coverage. So instead of drive testing outside, we're actually doing the same thing internally, inside buildings, inside tunnels, power plants, things of that nature.
Yeah, we will get into that in our
You can thank me later, Greg.
I think he wants another dinner tomorrow out of this. Okay, so this is the question that everybody always asks at a trade show. They see all the toys, they look pretty sexy, how much? So what's the high to low street price of some of these analyzers that combine multiple functions? Are these costing tens of thousands of dollars, or can I get something for $8,000? What's the range?
I guess it depends on how much you have in the unit. So you can probably buy a handheld spectrum analyzer for $2,000 by itself. And then if you add more components into your test set, 30,000, 50,000, and from there the sky can be the limit. So it's not so much prices are coming down only, it's just a matter of how much does the user need at that time. So if they only need a spectrum analyzer, but if you add an RF generator, spectrum analyzer, your costs start to climb. But they're climbing responsibly. It's not a matter of boxes are just going to be $100,000 because you have 4 pieces of test equipment in it. Most things now are processed mathematically within digital signal processing. So it's not more components, it's more software.
So does that suggest, George, that a lot of these instruments are software upgradable? In other words, you can buy just what you want today and then you can add in the other features later?
Truly stated, software defined, not just for radios, but now for test equipment.
Okay.
And our test equipment comes pre-packaged in the firmware virtually with all options we could ever offer. They just have to be turned on. You know, plug in a flash drive and activate a bit, and then that feature is now available for use. Or the standards change. The standards either the standards enhance or new standards created. Some software engineers jump on a computer, create a code, and then we can squirt it inside the box. We no longer have to add blades or slave a box to the back anymore. We can just software upgrade the test set.
But you have enough processing power on board to begin with.
I hope so.
Yeah. Tom, you want to comment?
Sure. On the low end, we have our Bird 43 watt meter. On the high end, we have products we're selling to people like Apple and Samsung that goes for tens of thousands of dollars. But you certainly see a price reduction. In the past, most people have probably used an Enritsu or a Bird product to do antenna and cable sweeping. And those were getting in the neighborhood of, $8,000 to $10,000. And our new one, which runs off a Droid platform, is $2,500, and it's a third of the size of what we used to make, so it's getting smaller and cheaper.
Wow. That's amazing. Yeah, sure.
From earlier, we were discussing how you can set a piece of equipment at a site and remote monitor either on a tablet, cell phone, or computer. I see a day where we'll get away from selling equipment with faces. No more monitors, no more keyboards, just a box with a connector, maybe some simple signal processing, and the rest of the processing is handled on your Surface i7 tablet. So the more processing power you have, the more readings you can perform. So supply an app, you provide the computing device with a face, the rest is just a small box with a switch and a connector.
So that's a trend that you see.
It's not a trend yet. I believe that's the ultimate future
Okay.
evolution. Because for manufacturing purposes, Apple may not let me put an iPad on my test box. So I can't, Apple buys 10 million displays a week or something, and I do 1,000 a year. So if I can get out of the display business, I can reduce my complexity of my unit, my stocking, my cost drop. Customers are better served.
Understood. You just answered one of my last questions, which is great. But we'll get back to that. So do these devices allow people with less experience, less training, to actually do more complicated things like interference hunting, PIM testing, and PIM discovery? Is that part of what's happening here? Or do you still have to really understand RF, or else you're just going to get kind of funky measurements?
And, I come from a land mobile background, and we've tried to add complexity to our technician training by showing them where the on button is. No, now with our auto test routines built into our boxes, we've taken OEM software that they issue normally, embedded in our test box. So with the radio, RF cable, and a USB cable, you effectively can select a model, radio model, press start, walk away, come back in 5 to 10 minutes, and the radio is optimized to factory specifications. Wow. What that does from a radio alignment test format is it frees up a good RF technician, RF engineer to do other more complicated things, not just sit at a bench. That mindset has gone away. Of tuning and the guy with the glasses and pocket protector, what have you. I don't need that anymore. And jokingly, I sometimes tell my customers that we've made it so that an 8th grade intern can test your radios for you. And you can go and check the site, check cables, or do some programming or what have you, and do more serious work. So Automation, because radios are digital, the pots are digital, the tuning is digital. It's not former mechanical components anymore. There's no need to sit back and tune a radio. Similar to your cell phone, it's constantly being tuned via software now. So your radios are in the same category going forward.
Tom?
I don't see any way we'll ever get away from the RF experience of people in this room. You know, we can build the boxes, we can spit out the data, but getting people to understand what they see, that's the hard part. Greg and I talked about this last night over a few drinks at the bar, and the problems that we see from our customers calling us simply not understanding how things work or even work together when systems are combined, public safety and cellular. So I think we continue to need smart people and good test equipment.
I have to agree with him, and I should add a component that we've started. Our company has started providing a digital workshop throughout the nation, and we try to attract as many customers as possible. It's not a workshop to sell our products, it's a workshop to discuss technology because it's not really taught. I mean, AARL or CB radio enthusiasts of the 70s, it's not the same today. You're not going to school to learn about deviation limiting, deviation balance, symbol clock error, BER, what have you, unless you're in the industry and maybe a vendor like Motorola, what have you, happens to train you. So that engagement is still needed. People are still hungry for knowledge. Maybe understanding what's happening as the unit's being tested is beneficial, not so much that they need to perform it directly. But good point, people are still hungry for knowledge. You still need smart people.
Yeah, I can remember being in the field and making measurements and having ground loops and other kinds of things that created extraneous noise on the scope of the spectrum analyzer, and the guys just didn't understand why it was there. So yeah, I think I agree with you. There's a need for some basic RF knowledge, and we've talked about it before. So what kind of training do you guys offer, if any, for techs and engineers on your test equipment? And what does it comprise of? Is it a one-day school? Is it a webinar? Is it a one-week classroom setting? What is it?
It's a combination of everything. Sometimes I tell customers, usually after you've been trained, as it were, you still have to get out there and make mistakes and experience the use of the product real time. Usually they're one setting away from success, and it's similar to your first introduction to your smartphone. I can't get it to do this, and you show it to your 5-year-old and you say, oh, just press this one button and it works. What we offer is ongoing webinars, pre-sales webinars, post-sales webinars for free. You can call up our tech support and have access to someone that will train you on a topic right now. There are plenty of YouTube videos on the operation of our product. Our sales team and sales reps are talented enough that a phone call away, how do I, where do I? We've embedded in our products baseline test routines that a customer can start from, extract it, make modifications to it, save it elsewhere as the particular test routine to use going forward, so they don't have to recreate the wheel every time. So our training, we do have paid training, but a good portion of our training is just free because it's usually single topic, how do I do this one thing, which is that last button push that they can't see.
Tom?
We're very much in the same boat. We're using YouTube videos. We have an applications engineering team. People like Ron used to work with us, but he got smart and retired, moved to Florida.
No RF in Florida?
Well, when Ron retired, he actually told me that he was going to tie his snow shovel to the top of his car and drive south till someone asked him what it was, and that's when he knew he'd be home. But I assume you have RF in Cocoa Beach. Oh, yeah. But we like Aeroflex or Cobham, we do all the above. One-on-one training, we have classes we certify through the ETA, 2-day, 3-day classes, online webinars, work with our distributors.
But it sounds like the webinar is really the medium of choice, yeah, because it's inexpensive, nobody has to go anywhere, and it's as you need it kind of thing, yeah. Okay, so we come to my last question. George kind of answered it before, but he can get another shot at it, but I think I'll start with Tom. So what changes do you expect in the test equipment industry in the next, say, 3 years? What do you see in the future in terms of broad trends?
Broad trends, I would say embedded sensors. Right now, we put a Bird 43 watt meter on the output of a radio. I can see us putting a sensor inside the radio, maybe having Bluetooth coverage to your phone, so the technician can walk up, key up a radio, and just look at his phone to see what the power output is. We also see a lot of trends in the remote monitoring, so less and less site visits, more and more technology available from wherever you are in the world.
Cool. George, you want to give another shot?
Give another shot. I think I'm back to miniaturization of product, getting the boxes smaller. Again, moving the processing of signal analysis off of the test set onto a user-owned device, so that we're not integrating more and more chips inside of our test sets, but the user, depending on the quality of their PC, tablet, or what have you, can determine how much testing they want to be able to perform. So smaller test sets, more easily manufacturable test sets. So the test set's dumb until we give it a personality. Today you're going to be this, tomorrow you're going to be that. For the future of LTE, you're looking at your ability to differentiate on the waveforms, capturing the signals, determining what's real and what's not real, and minimizing errors.
Okay, good. All right, so we have about 10 minutes left. It's your chance to ask questions. I think what we'll do, let's see, how are we going to do this? I'll give up my microphone, and no, you guys keep that one. Oh, you guys keep that one, and Dave will bring this one around.
As you're talking about the miniaturization of the equipment, how far away are we from integrating test equipment with drone technology, where you can strap one of these onto a drone and have it do RF surveys as well as interference targeting?
Last time I used a drone, it just had a camera on it. You can turn the camera off. I don't know. I'm not in that industry. I don't know how far away we are, but the limitation on a drone would be weight and power consumption. So there's probably a box that can fit on a drone now, but can the drone fly and give you an appropriate mission life?
A lot of the drone technology now will support a 35-pound payload and fly for a half hour.
I was speaking of a smaller drone. You're talking about more of a military application. They're probably already working it for Hollywood.
Yeah, they're strapping. Last year at NAB, there was a lot of drone technology using the LiPo batteries, and they're hauling around cinematography cameras that is basically getting away from using helicopters and using digital SLR cinematography cameras to do a lot of that technology. So they're carrying about a 30 to 35-pound payload now.
I was at NAB. They're very impressive drones. But I do have a radio dealer in Miami that's doing just that, and he has become a certified drone operator just for that application.
Yeah, Charles Kermis, I've seen the evolution of a lot of the test equipment that George sells and other companies. One of the things where the portability aspect has always come out now, which I appreciate, being out in the field doing surveys up on towers and RF rooms and so on. One of the problems is we focus so much on, and this is something for you guys to bring back to your engineering department, we focused on so much on how to make things easier, more analysis, and one-button steps, where when you have a portable monitor outside in the field, God bless the old CRTs, because you can see them out in sunlight. And I've seen for $20,000 piece of test equipment from several manufacturers that you have to build basically a shed over your head to be able to see the analysis. So please go back to your factories and please indicate where we need good NIT, good nit, good bright screens that operate in sunlight with a wider field of view. because it's embarrassing when you have a $25,000 kit that you really can't use outside, especially when you're somewhere in between downstairs and upstairs on the upper deck where you can't safely protect yourselves. And to bring in the cost of a higher NIT screen output is insignificant. And it goes back again to, these devices are actually the worst.
Thank you.
Could you comment on that, George? Can you bring that
No,
back?
that's truly an engineering question, whether or not we can integrate that in existing product.
Got a question actually for each of the manufacturers, Cobham, AKA IFR, and Bird. Many of us are using test equipment which is 20, 30, 40 years old, in the case of my watt meters probably. How long do you as manufacturers support that stuff from a practical point of view? I mean, my lab also has some of the new stuff in it, but for some of the reasons the gentleman just previously pointed out, sometimes older is better. So far, I've been able to maintain this equipment through factory resources, but at some point, I'm going to be told that's not practical and get pissed off. So at what point do you really pull the plug?
We've pulled the plug on some of the older test equipment sets years ago. That doesn't prohibit third-party individuals from collecting surplus product and trying to cannibalize to keep it alive. But when we ran out of the ability to acquire switches or CRTs for certain monitors, we had to stop supporting it. You run into a situation where parts are no longer manufactured anymore. So the result is, can I find an old box that maybe the screen doesn't work, but the generator does work, and I'll just have to continue cannibalizing until I run out. Things will attrition away. A COM 120 may not last another 30 years, although it's a fine analog piece of test equipment. 1200 also won't last forever. I like the switches and the toggle switches and the knobs, but at some point we can't. The parts aren't made anymore. The chips aren't made anymore. So the newer test equipment has analog components in it. Probably even has better deviation meters, what have you, so you can get more accurate readings now. So we don't want you to keep using the old stuff forever. We want you to buy new.
From a numbers point of view, we try and keep parts availability for 7 years once we obsolete something. But I saw Ron chuckling when you asked the question because the Bird 43 watt meter is still available, and I'm 53 and they started selling it 10 years before I was born, so I don't think we'll ever kill it.
Thanks for being here on the panel. So I once said that Moore's Law is the biggest threat to test and measurement because SDRs are now quite inexpensive. People can build reasonably good spectrum analyzers out of DVB dongles and Raspberry Pis. There's a person in this room who built an antenna analyzer for $50 that works and correlates almost to an Anritsu cable to a SiteMaster. What do you see in this? Do you see trends towards people essentially rolling their own test equipment? You talked about drive testing. There are apps on phones that will do the drive testing for you. It's crowdsourced drive test data. You don't have to drive test it because the users of the network are drive testing it so therefore drive testing becomes less important. What are your thoughts on this trend?
Well, from a cellular consumer standpoint, you've got your built-in test network from consumers not getting the service that they desire. From a land mobile radio serving public safety standpoint, the comm managers want their own personal access to that information that they can manage and manipulate using high-res maps. As far as generating your own device for an enthusiast, have at it. And maybe you can change the marketplace and create a paradigm shift. I'm not sure of our trend towards drive testing with software, GPS receivers, and a radio will divert to a $50 box or so because of professional quality. If it does, yay, it'll be better for the marketplace.
One thing about that, I was going to make a comment on current drive test situations because we do it all the time. Today, this phone has it has everything in it. It will give you the data. However, Verizon and AT&T and T-Mobile in the United States lock it up. Used to be a secret code. You know, if you knew the code, you could get into the engineering. Now, it's no longer a secret code. You have to know somebody in the carrier to actually get their API to drop onto this. There are available things, like you said, that are on the available on the internet. However, they don't show you the data that you're going to really need to be able to look at handoff parameters, that sort of thing, that are necessary for true drive testing. And I think it's still a commercial operation. You know, there's 3 or 4 vendors that deal. We have one that actually takes a smartphone, and they tell me they spend 80% of their time dealing with the lockups that the carriers put on the smartphones, even though they have permission to get rid of them, because they're making it harder and harder for us to truly get network information off of the smartphones. So it's going to be interesting to see what happens, over a long period of time with that. I would love to see it, because every time something new comes out, like LTE, Agilent charges us about $25,000 a year to upgrade our software to look at it. So.
It was mentioned earlier that from a spectrum analyzer perspective, you guys are pushing more and more power level measurements that go beyond peak to average power levels. Does that include the reference signal power levels? It does. Is that available today?
Yeah, we have a statistical power meter, so you can actually put, like George was saying earlier about removing the screen, this is something you plug into your computer, and then on the computer screen, I can actually put cursors on the signal anywhere I want to and measure the pulse width in between the 2 cursors.
Okay. We're currently evaluating a real-time spectrum analyzer that's roughly about 3 pounds. No user interface. It's all software driven at relatively low cost at a starting price. And where the get you is in the software application, where it could really scale up. So.
That's exactly right. $25,000 piece. $3,000 pieces are.
One more question.
Has there been any security concerns with some of the new test equipment where you can record signals and play them back to, say a garage door opener or a key fob thing where you can record the spectrum, you can see exactly what it is, and then recreate that transmission to break into cars, open garage doors, et cetera. Has that come up?
First time anyone asked me, this was just last week actually, and as it pertained to our equipment we can put on the Ethernet, and I don't think Bird as a company has really gotten into IT security because everything's going on to a private network that our customer owns. But we have a division of the company called Icom, and that's basically, I'll say, a military application we use against our enemies, very much so, the ability to record and capture their RF signals and then reuse it against them.
It's not come up as far as a security concern from a manufacturing standpoint, although we have test equipment that can read the signal, dissect it, and help us reconstruct it. Fortunately, we do it for benevolent purposes and not for malevolent purposes. But even if it was an issue, how would you stop a person with a criminal intent from taking that test equipment and using it in that fashion? I don't know what safeguards could be put in place to prevent someone from recording a garage transmitter or even a vehicle transmitter signal and trying to develop an ability to mimic it to gain some advantage. I don't see any trends in that area. That's not where we focus on. We're primarily land mobile radio. But again, like I said, if that ability is available for someone, they can still use it for good or for bad.
Okay, we're going to go to the next presentation. Thank you, George and Tom. Please don't forget to mark your presenter forms.